This video is going to review Chapter 3, Section 4, which we did before Christmas break, and specifically review how to use your graphing utility to help you out in those scenarios. So the first thing is, when do we use these? And we do it when it's not factorable. So if our polynomial can't be factored by, if it's 4 terms, like if you can't factor it by factoring by grouping, or if it's just 3 terms, if you can't factor any other way, then this is our game plan, which is to put the polynomial in order of decreasing degree, so highest exponent down to none, and then find all the possible roots by doing plus and minus the factors. So this is factors of the last number over the factors of the first number. And the plus and minus means that each of those will have a positive and a negative, and you don't need to repeat them. So if it happens twice, you just need it once. And then you'll use your graphing utility to find one of the real roots. This might be a fraction, but it will definitely match something from your possible banks. And then you'll use synthetic or long division to reduce the degree of the polynomial using that one that you found. And then by reducing it down to either x to the third and then factoring by grouping, or if it starts as x to the third, we reduce it a degree to x to the second. And that's when we will use the quadratic or factor it to find the remaining factors. So we start with example 1. It says find the solutions or zeros or roots, because these will all be the same, of the equation. And we look at this and first realize that this is not, you can't factor this by grouping. From the second 2, you can actually take out that 4, but it won't match the first one. And the first one, obviously, we can take out the x squared, but it won't match. So we're going to make sure it's in order of decreasing degree, which it is. And then we're going to do plus and minus the factors of the last term. So 16 would be 1 and 16, 2 and 8, and then 4 and 4. And then factors of the first one, which is just 1. So I do plus and minus 1 over 1, 2 over 1, 3 over 1, 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1. So this is our possible roots. So the real rational roots have to come from here. There can be roots that have i's in them. There can be roots that have square roots. But any kind of real number, whether it's a fraction or a whole number, would come from this possible bank. So without a graphing utility, we would literally just have to keep trying 1 and then -1, 2 and then -2, 4 and then -4 until we find one that works, and we would know it works because the remainder would be 0. Or we use our graphing utility, which is what we're going to do next. Okay, so if you haven't already grabbed your graphing utility, you want to grab that calculator. And then I'm going to use the TI-84, but you can use different ones. The first thing we're going to do is click on the y equals, and we're going to type in that equation. So x to the third plus 2x to the second minus 4x plus 16. I'm going to hit enter, and I'm going to graph it. And from my graph, I see, and I don't know if you noticed, but in the top right corner, it was spinning when it was graphing it. It's done spinning, so I know this is done graphing. From my graph, I can see it only crosses through this axis once. This time, it's a whole number, so we're going to kind of baby step our way into what that might look like. So I can not only see it from my graph, I can also see it from my table, so second table. And I'm looking for y is 0, which is at -4. That will show you a whole number. If it wasn't a whole number, I would have to go back to my graph and trace it. So second trace brings me to calc, and I'm going to find my 0. I would want to go left of my intersection, and you can see the y is getting bigger. Or sorry, the y is getting smaller, so I want to come back until it's past 0, so it's negative there. And then I want to go to the right of it, or bigger than 0 for y, which is there, and then guess, and it's going to bring me to that point. So again, it's -4 this time. It was easy to spot just from our graph. They're not going to be like that all the time, so we want to get practice on finding that 0. Okay, so now I know the 0 is at -4. All right, let's try another one. So again, find the solutions, zeros, roots of the equation. First thing we're going to do is make sure it's in decreasing degree order, which it is. Identify the first and the last terms. Factors of the last would be 1 and 8, 2 and 4. Factors of the first would be 1 and 3. So this time my possible bank is all the numbers here over 1. So it would be 1, 2, 4, and 8. And then all the numbers again, but this time over 3. So I'd get 1/3, 2/3, 4/3, and 8/3. Now we're going to use the graphing utility to graph that one. I'm clearing out the old y. And I'm typing in the new one. So 3x to the third minus 2x squared plus 12x minus 8. And this time we see from our graph, again, it's only crossing through once. And this time it's not a whole number. So when I go to table, I won't see where y is 0. It actually skips from -5 to 8, which means I'm going to go back to my graph and I'm going to need to trace it. So second trace, go to 0. Left bound, it actually is left as it is. I can get it closer, but I don't need to. It's already left of it. And then right bound, my y is positive, so I'm right of it. Oops. Try that again. Left bound, right bound, hit enter, and it brings me to the 0. So this time my 0 is a decimal, which is what I expected. 0.6666 repeated till you get to 7 means that that 0 is actually 2/3, which matches one of my possible roots. So now the answer that I know is one of the roots is 2/3, and it should be the only real one, judging from this graph. So I'm gonna have to take 2/3 and put it on the outside of my synthetic division. I'm gonna grab all these coefficients. So +3, -2, +12, -8. And bring down the 3. 3 times 2/3, the 3's would cancel and it's actually 2. -2 and +2 is 0. 2/3 times 0 is 0. Add to the 12, I get 12. And 2/3 times 12, 3 goes into 12 4 times. So it'd be 2 times 4, which is 8. And there's the remainder of 0 we were expecting to see. So I know that 2/3 is confirmed to be right. And now that's my remainder. The 12 gets left as the +12. It would be 0x and 3x squared. So 3x squared plus 0x plus 12 is just 3x squared plus 12. From here, I want to set this equal to 0. And I can either use the quadratic where a is 3, b is 0, and c is 12. Or because there's not an x squared and an x, I can actually use your even root property. So I'm going to use square roots to subtract the 12. 3x squared would equal -12. Divide both sides by 3. X squared is -4. Square root both sides, making sure to do that plus or minus. That's the even root property. And I get x equals plus and minus. I comes to the outside, and the square root of 4 is 2. So 2i, which is consistent with there being no other real roots from my graph. So my answers are the 2/3 I got from the graph, -2i, and +2i. Okay, we're going to do it 2 more times. So example 3, again, making sure it's an order of decreasing degree, which it is. Finding the possibles, the factors, the last one would be 1, 15, 3, and 5. The first would be 1 and 2. So my possibles are plus and minus 1 over 1, 3 over 1, 5 over 1, and 15 over 1. And then 1 over 2, 3 over 2, 5 over 2, and 15 over 2. Now we go to the graph. So this time I already typed it in. There's my 2x to the third minus 3x squared minus 10x plus 15. And then I'm going to hit graph. And from this graph, I can see that it's actually going to cross through the x-axis 3 times, which means there's going to be 3 real root answers this time. But I can also see from here that none of them are whole numbers, so they're not going to show up in the table. I'm going to have to trace them. Now, if I look back at my possible roots, though excluding the whole numbers, they're all over 2, which means they would all be at the halfway mark. So if I look at the 3 times it crosses through the x-axis, it looks like that middle one is the one that crosses through in between the 2. But let's just say we didn't catch that. And we went and did second trace, and we went to 0. And we wanted to graph to find the first one. So I'm below the x-axis. I'm going to hit enter on the left one. I'm going to cross so that I'm higher than the x-axis. And I'm going to hit enter on the right and then guess. And it's going to bring me to that point, which is like negative 2.2, which is not one of my possible roots, but I'm going to write it down to remind myself for that later, because that should come in handy when we're checking our answers. Now I'm going to do that again. Second trace, go to the 0. This time I'm going to go to the second one. Now notice the y keeps getting, now it's smaller. It's coming back down. And there it is on the screen. As long as it's left of that 0, I can enter. Then I want to go right of that 0, which again just means below the x-axis, so the y is negative, and hit enter and guess, and it's going to bring me that 1.5. 1.5 was one of my possible roots. 3 over 2 is 1.5. So I can go again and see what that next one is. It's obviously something like a 2 point something, but I don't even need it, because from here I'm going to use that 3/2. Okay, last one. So same process. Find the solution, zeros or roots of the equation, making sure it's in order of decreasing degree. This time, if I were to graph this, if I were to factor it, I would get x squared here. I'd get x plus 2, positive 9, x plus 2, and this would actually factor the x plus 2 would give me the real root of negative 2, but the x squared plus 9 would have to get set equal to 0. X squared would equal negative 9, and x would equal plus and minus the square root of negative 9, which is plus and minus 3i. So this time we can actually find our roots by just factoring it. So you always want to check for that. And we want to confirm it with our graph, because that's how you would be quizzed. That's how you'll see this on a quiz or test. So we're going to type in our equation, x to the third plus 2x squared plus 9x plus 18. Oops. And graph. So from our graphing utility, we see that it crosses through at negative 2 and only negative 2, which is consistent with the other ones being imaginary. We're going to confirm it with our synthetic division. So if it were to say show that your root is a real root, you would do the negative 2 on the outside. It'd be 1, 2, 9, and 18. Again, that comes from these numbers up here. Bring down the 1, negative 2, 0, 0, 9, negative 18, 0. Remainder is 0. 9 stays as 9. 0 would get the x. 1 would get the x squared. And I'd have x squared plus 9. Set it equal to 0. Subtract the 9. Plus and minus the square root of negative 9, which is your plus and minus 3i. So that matches what we got from our factoring. It was way easier to factor, so you always want to check that. But most likely anything on a quiz or test on this section would not be factorable because you'd be forced into using that graphing utility. Okay, guys, don't forget that you're submitting the notes for today. Do that now. It has to be before the end of the class period, and then use the remaining time to work on your homework. I think it's extra practice. Have a fantastic day, guys.